In this video, we're going to talk about propositional logic. Now, just as a small intro, chapter 1 of this textbook is focusing on arguments, logic, and proofs. So we're looking at reasonable things that we're able to do, and it allows us to kind of set up structure for ideas that are heavily used in computer science and mathematics. So let's start with a definition. A proposition is a declarative sentence that is either true or false. Okay, so here are some examples of propositions. The moon is made of green cheese. Trenton is the capital of New Jersey. Toronto is the capital of Canada. 1 plus 0 equals 1 and 0 plus 0 equals 2. Now, clearly, some of these are false, and that's fine. That makes it a proposition. It has an actual falseness to it, or truth, okay? Examples that aren't propositions. So a declarative thing like sit down, there's no true or false to that. Or what time is it? A question wouldn't count. Or anything with variables don't count as propositions because there's no true or false nature to it. Okay, so that's what we have when we're looking at propositions. Now, what's nice is propositions, because they have this true or false nature, we're able to work with something called truth tables. So let's look and see what that is. The first type of thing we're going to look at for a proposition is what's called, or these are called compound propositions, by the way, is the negation of a proposition. So the negation of a proposition, they use this little symbol. Now, there's actually two versions of the symbol, and I went ahead and included them both here. Sorry, I just realized I needed to select the correct thing. So there is this version, which is what you'll see in like the homework, and then this version, which is the little like squiggle. They both refer to negation, okay? And here is the truth table for it. So there are two possibilities for our original proposition. It could be either true or false. The negation of our proposition is changing its truth value. So if it's true, it becomes false when we negate it. And if it's false, it becomes true when we negate it. Okay, so let's look at an example. If P denotes this proposition, the earth is round, then the negation of P would denote the earth is not round. That would be the negation of that proposition, that statement. All right. One's true and one is false. And if the original statement had started as a false statement, when I write the negation, that one's going to be true. Okay. There are more than one ways to write the negation, by the way, because the English language has more than one way. Just so you're aware. But yeah, it's possible to say that a little bit differently. All right. So we're going to introduce another idea that's called the conjunction. All right, the conjunction. The English word we use to denote conjunction is and, the statement and. And the symbol we use is this like upside down V, okay? And the truth table for and looks like this. Okay, so if P is true, Q could also be true. When P is true, Q could also be false. When P could be false, Q could be true. And when P is false, Q could also be false. So those are the cases that P and Q could be. All four cases. There are variations of true and false. All right. So we're accounting for all possibilities. The case where they're both true, or the case when only one of them is true, or the case when both of them are false. All right. So if we're talking about and you say that two true statements with the conjunction and, that comes out to a true statement. So if you put two things together that are true with an and, that is a true statement. If you put something that's true together with something that's false, using the word and, that actually becomes false. So let me give you an example. Let's say I told you that my dog, Ted, is 70 pounds. All right. And then I told you that my I also am 70 pounds, which is absurd. Okay, so if I say those two things together, if I say my dog Ted is 70 pounds and I am 70 pounds, the first statement could be true, right? It is. But the second statement is definitely not true. So what I just said there becomes false. All right. When I pair something with false statement in the word and, it's that word and that matters, that causes the whole thing to become false. So that means this next one here, this is false because the first statement would be true, and I'm sorry, false, and the second one would be true. And then when both statements are false, it comes out false. All right, here's an example written. If P denotes I'm at home and Q denotes it is raining, then the statement P and Q, or P with the conjunction Q, would be I am at home and it is raining. That's how we would put them together using the conjunction. Okay, so I want to show you putting these two ideas together, how that could work in a truth table. So my goal is to make a truth table for this statement right here. So I'm going to put that into, oops, my last column. And here I want to zoom in a little just so I can see better. There we go. Okay, so I'm going to put that here, P and not Q. Okay, so what's different about this one is I'm using this idea of not Q. And you see I have a column here for that. So in this column, I'm going to figure out what not Q looks like. All right, the negation of Q. Okay, so I start every truth table pretty much the same way. I start with doing P as true and then false, and then I take Q and I do true, false, true, false. So I'm pairing all possibilities for P and Q. Okay, so not P. Here, let me switch highlighter colors here just so I can make this clear. So this column right here, I'm going to base it off of this column right here. So I'm going to use this to figure out what not Q is. So when Q is true, the negation of Q is false. When Q is false, it's true. When Q is true, it's false. And when Q is false, it's true. So it's the exact opposite. The truth value is the exact opposite. Okay, cool. Now I'm going to take this column, P, and not Q, and I'm going to fill out this column based on those two. So I'm ignoring the Q column now, and I'm focusing on just those two columns right here. Okay, so for conjunction, if one of them is false, the whole thing is false. So in this first row, since Q, it's not Q and it's false, this whole thing is false. Okay, the second row here, they're both true, so this comes out true. The next row, they're both false, it's going to be false. And the last row, one of them is false, so the whole thing is false. So this is the truth table for P and not Q. By the way, that's how we say that. You just write that down. P and not Q. That's how we say that in English. Okay, let's look at another type of compound proposition. This time we're going to look at something called the disjunction. So the disjunction, I just realized they didn't really say it. It should be saying or, not and. So here, that should say or, not and. They made a mistake there. P or Q. So it's using the or. All right. Now in this case, or means that if one of them is true, the whole thing is true. So it's like the opposite of what and or the and is, the conjunction. So in this case, when they're both true, this comes out to true. When one of them is true, it comes out true. When one of them is true, it comes out true. The only case where we're going to have false is when both propositions are false. All right, let me give you an example here. So I am at home and it is raining. So if we want to write that with the disjunction, we would say I am at home or it is raining. And if one of these happens to be false, that doesn't make what I said false. The statement here is not false. So if it happens to be I'm not home, but it happens to be raining, then what I just said is still true. Okay. So in English, or can have two meanings, the inclusive or the exclusive or. So let's talk about that really quick because they actually make a distinction between this. Inclusive or means either one or both must be true. That's what inclusive or means. All right. So when we say, let's say here, let's see, students who have taken Computer Science 161 or Math 231. It's possible that it could be that they've taken just Computer Science 161 or just Math 231 or both. All right. That is the inclusive or. It doesn't have to be one or the other. It could be both. Okay. Exclusive, though, is the idea that it has to be one or the other. All right. And they use a special symbol for the exclusive or. I want to switch back to my other highlighter here for a second. For the exclusive or, they use this circle with a cross. And the way they pronounce that is XOR. An X with the or. So exclusive or XOR. All right. In this case, it has to be one or the other must be true. Okay. So like, let's say that a soup or salad comes with an entree. What that means is you only get one or the other. You can't have both. Now, you could buy an extra one, but included with the entree is only one or the other. Okay, that's exclusive or. And this has a different truth table for that reason. Okay, for the exclusive or, we could have. Sorry, let me write all the trues and falses here. Okay, so true, true, false, false, true, false, true, false. Okay, there we go. Okay, so for the exclusive or, they can't both be true. This line is a problem. They can't both happen. But this is okay. You could have true for one of them. And then if they're both false, it stays false. So for this one, this or, the trick is understanding that they can't, oops, oh, I'm so sorry. I thought I had selected the highlighter. I did, it just didn't catch up with me. The trick is understanding that both of these need, if they can't both be true, it has to be one or the other that's true in order for it to make sense. You can only have soup or a salad. You can't have both, okay? Okay, so let's make a truth table with this and using the not Q this time. So I'm going to include not Q here, and then I'm going to include the XOR here at the end. Okay, so true, true, false, false, true, false, true, false. Okay, so not Q. I'm going to swap all of these. This is going to be false, true, false, true, right? I'm looking at the Q column, this column right here. Okay. And then for the last one, I'm going to be looking at P and not Q. All right. So in order for it to be true, it has to be one or the other that's true. Okay. So this one works. Only one of them is true. This one's a problem. They can't both be true. Can't both be false. And okay, but that one works. So there you go. There is the answer to this. Technically, just so we're clear, the answer, quote unquote, is the last column. That's the truth table. But on the homework and on the exams, we're going to show all the work in these tables. Okay, so we will have the whole table so I could see how you came to your answers. That way, if you make a mistake, I'll know where your mistake was made. Okay, so let's try another one, a more complicated one. So this one, I'm going to need to find not P, and then I need to find this. I need to find not P or Q, and then I could find not P or Q, XOR P. Need a little bit more space in my last column. That's all right. Okay, so true, true, false, false. True, false, true, false. Okay, so not P. I'm going to be the opposite for this column up here, right? The front column. Use that highlighter, that column for not P. Okay, so that's going to be false, false, true, true. Okay, so now I'm going to use not P or Q. Okay, so for this disjunctive, we can have both of them be true or one of them be true. So, and you could always, by the way, don't be shy. You could always go back and look at the truth table we did for it. Okay, so this is the truth table, and you'll get better at these as we go. All right, you'll start to learn them. But for this, the only case that's false is when both of them are false. This last one here. Okay, when both are false, then it's false. Otherwise, it's true. Okay, so come back. There we go. Okay, so looking at the two highlighted ones, true, false is true. Okay, so false, false is false. True, true is true, and false, true is true. Okay, now let me go ahead and erase my two highlighted columns. For this final one, we're going to look at what we just did here and P. And we're using the XOR. So they can't both be true. So the first one is false. Second one is okay. That's true. Third one's okay. And actually the last, there we go. Okay, so there is our truth column or truth table. Technically, this last column is the answer, but we had to build up to it. And I will go ahead and move into the next topic in the next video.